Well, hey now, wanted to do just a couple slides here. This won't take long at all about rational expressions. A rational expression, remember, a ratio is a fraction. So we're talking about fractions here, except they're algebraic expressions. Got some for you to look at and think about. And um, here you go, right here. Okay. Over there on the left-hand column, I've got a trinomial over a trinomial. And, it's tempting to come in here, and I'm not recommending this because this isn't right, but, it's tempting to come in here and go, well, let's see, here's an x squared on the top and an x squared on the bottom and an x and an x, and, try to cancel stuff like that. It doesn't work like that. Okay. Don't go doing that because you can't do it. And I'll tell you why. That x squared is part of this whole big thing here. And you're you got to pull it out of the whole thing. All right. So that's not the right approach to this. If you have addition or subtraction on the top or the bottom, then that's all one piece. And to untangle it, about your only choice here is to factor it. In this case, with addition, subtraction, like you see there. So um, let's see if we can't factor these things. Now, we talked about factoring last time, so hopefully that's still kind of fresh. But if I try to factor the top and factor the bottom, sometimes some nice stuff happens and it'll cancel out. Looks like I need an X and an X, and the first times the first. My factors of 16 would be 1 and 16, 2 and 8, 4 and 4. And I notice that 4 and 4 add to 8. So pretty good bet that I could put the 4 in the 4. Of course, the signs are the same, and they're both positive. So that would be x plus 4, x plus 4. And we've got the top factor there. You can check the FOIL, but we will definitely get back to where we started. This x squared is going to be x times x. 28. 4 and 7 is 28, and that does add to 11. And again, the signs are the same, and they are positive. Okay. So I'm looking at an x plus 4, x plus 7 here. And now I can cancel some stuff. When it's multiplication on the top and the bottom, then it's perfectly okay to go ahead and cancel that stuff. And this one on the top, x plus 4, and that x plus 4 on the bottom, you've got a common factor there. You got whatever you want to call it. Top and bottom, those will cancel, and I'm left with that right there. It would be good to just check and see if anything cancels. And of course, it doesn't. Again, it looks like you want to, a lot of people would want to cancel those X's. You can't do that because same reason, right? That's that's part of a bigger thing, and you gotta root that out before you can go canceling stuff. So I'm left with an x plus 4 on top and an x plus 7 on the bottom. And anytime you can uh, factor and cancel in a rational expression, that's a good day. Okay. Over here, I have two fractions that we're looking at. Um, and looks like I could factor some stuff here. Let's try this part on top here in the first fraction. I'm going to try x, and then factors of 2 that add to 3. Oh, that's easy. The signs are alike and positive, so x plus 1, x plus 2 would work real nicely. Down here on the bottom, need an x and an x again. Factors of 6. I need two numbers that multiply to 6 and add, and right here the signs are different. So effectively they need to subtract to give me a -1. If I had a 3 and a 2, that would do. The signs are different, so one needs to be positive, one needs to be negative. Which one's which? The big one needs to be negative. So that's the 3 there. Remember that we're saying here's a 2x and there's a 3x, and I need -3x plus 2x. So that would be the proper factorization there. All right. Here, perfectly okay to go ahead and say, you know what? I've got an x plus 2 top and bottom. I could wait and maybe cancel it with something in the second one, but that one's ready to go. So we might as well send it on its way. Right here, I'm looking to factor this thing. Now, this has only got two terms, but there are some common factors in those, right? I've got a 3 in both of those. So let's pull the 3 out right there. 3, this is 3 times 3. And then there's an x in both terms. So let's pull the 3x out. And right here, I need something times 3x to give me 3x squared. That would be x. I need something in the back here, 3x times something to give me negative 9x. I've already got the x, so I just need a negative 3 right there to take care of that one. On the bottom, two terms, but they're both perfect squares. Look like I need an x and an x. One is a perfect square, right? One times one gives me that. And when we see the difference of two squares, we know one of them's positive, one of them's negative. You could FOIL all this stuff out, make sure that it all happens right. But we're looking for more stuff to cancel. So let's move along here. I see this x minus 3 on top and another one on the bottom. So I'm going to cancel the x minus 3 on top with this x minus 3 on the bottom. Perfectly okay to go all the way over to the other fraction because right there, remember, we're multiplying these two fractions. So the whole top is multiplied and the whole bottom is multiplied. I really could kind of continue that line there and make one big fraction out of it. Anything else? Oh, here's an x plus 1 on the bottom. So those will go away. Whole bunch of stuff. Just slash it and burn it here. I got a 3x on top and an x minus 1 on the bottom. I believe that's all I can do. No, I can't cancel the x because there's addition, subtraction right there. 3's not going anywhere. That's as good as it gets, right? And that's a whole lot better than what we started with. So that's a pretty good day's work. When I come over here, these are addition, subtraction problems. On the last page, we did multiplication problems. This is addition, subtraction. And I want to remind you that when we add fractions or subtract fractions, like the one way over here, I have to get a common denominator. And let's just remind ourselves here that anytime I have two fractions. I'm going to pick some numbers here. If I had 2/3 and, oh, I don't know, let's go with 3/15, something like that. If that's my problem and I'm trying to add those two fractions, I don't know why I put it so low because I don't have room to do this problem, but I need a common denominator, and here that common denominator is going to be 15. 3 goes into 15 5 times, right? So effectively, I have to multiply this number by 5 to get a 15 on the bottom there. And if I do it on the bottom, I got to do it on the top so that I keep that thing even. Those times 5s will effectively cancel out. And you know what? It would be even better if I hadn't put the x's in there. So let me go back and write that with parentheses just to avoid any problem here. I'm going to multiply the bottom by 5, multiply the top by 5, like so. And now everything's going to be in 15ths, and let's see what that'll look like. Here's a 15. 3 times 5 would be 15. Up top, I got a 2 times 5 is a 10. Over here, I already had a 15, already had a 3. I don't do anything with that. Now that I have a common denominator, we're going to have to go to the left here. But we're going to keep that common denominator and then add all the way across the top. 10 plus 3 would be 13/15. Well, we need to do the same thing with all three of these. These are all addition, subtraction of fractions. So we got to get a common denominator. And you know what? Look at that. There's almost the same problem. Forgot I had one with numbers. Knew I wanted to do one with numbers. I put it in. I didn't do it. All right. So same thing we just had. While we're stuck right here, while I've got this, let me show you a little slick trick to do this. I'm not saying this is the quickest way to do it, but it always will work. We may have to reduce it in the end. It's not going to be the least common denominator. You can take the 5 times the 2 and get a 10, and the 15 times the 3 and get a 45, and then multiply across. 15 times 5 is 75, and that's going to be 55 over 75. And that's one way to add the fraction. Now, obviously, I can pull a 5 out of there, maybe some other stuff, right? If I divide top and bottom by 5, now I'm down to 11. What would that be? I'd have a 5 times 3, 15ths. And I think that's probably the best thing that I can do. So I did have to reduce it, but that's kind of a neat little trick that you can do. Essentially, there, what you're doing is you're kind of cheating and saying, I'm not going to go for the least common denominator. I'm going to go for a common denominator. And the 15 times the 5 will always give me that. And so I'd really have to come in here and, it's like you're multiplying by 15 top and bottom here, and you're multiplying by 5 top and bottom here. And 15 times 5 is going to give me my 75. 2 times 5 is 10. 3 times 5 is 45. You add across there, get you 55 over 75, reduce the fraction. So, maybe that's worth knowing. It's another little way to come at the problem. And these two were different, slightly different problems. So we did get slightly different answers. Anyway, here's one with variables in it, closer to what I wanted to work up to here. Again, adding fractions. I got to have a common denominator. And here I got to have a factor of x and I got to have a factor of y. So my common denominator should be xy. And I need to get both of those with an xy on the bottom. All right. So this first one here, I've already got the x. I need to multiply by the y to get the xy. If I do it on the bottom, got to do it on the top. And that's going to give me a 5y. Over here, I've already got the y. Need to multiply by an x. Now I've got xy. Flip the order if you feel like it. And there's a 6x on top. I now have my common denominator, and that common denominator is xy. And I can just add across the top and get 5y plus 6x. I don't see anything that's going to happen there. The top won't factor. Nothing cancels. I've got that addition, so it would be hard for it to cancel. That looks like about as good as it's going to get right there. So we'll put that in. Okay. This last one here is the last one for this. And so let's think about what we need to do here. Obviously, there's some stuff we could factor here and break this down. That would be good because I might find an x plus 2 and or an x plus 1 in there, which would mean that I wouldn't have to multiply by this and that, right? If I have to multiply all three of those denominators to get a common denominator, that's going to be an unholy mess. So let's see what happens here if I go ahead and factor that first denominator. We're going to leave the numerator alone. Downstairs, we could do an x and an x, and factors of 2 be 1 and 2. Those do add to 3. The signs are alike and positive, so plus 1, plus 2. And see how those are the two denominators we already had over there? We don't have everything that we need, but we've got a good start now. And I'm going to write everything in here like it is. Put some parentheses just to hold stuff together and leave a little bit extra room. This one already had an x plus 1. We'll band that up. There's an 11 up there. So let's see what we need to do. Here, I got to have a term. I got to have a factor of x plus 1. Got to have a factor of x plus 2. Got to have a factor of x plus 1 and a factor of x plus 2 over here. I already got them, right? This one needs an x plus 1, which means I need to put it on the top as well. This one already has the x plus 1, but not the x plus 2. So I put it on the bottom, got to put it on the top too. And so now I have a common denominator. And I could just keep that common denominator, x plus 1, x plus 2. And I could add or subtract all the way across the top. Now, I did make one little typo here. Notice that that was a subtraction up there, and I wrote a addition sign. So I need to clear that out. And let's correct that real quick here, because I will get myself in trouble if I don't watch it. All right. But I need to take all the way across the top. I got a 4x minus 3, 4x squared minus 3. To that, I need to add x plus 7, x plus 1. And You know what? I've got some x squareds here. If I FOIL that out, I would get some more x squareds, which would mean I could combine them with these x squareds. So let's go ahead and FOIL this as we go. We're adding, but I've got an x times an x, which is an x squared. I've got a 1 times x and a 7 times x. That's going to be 8 times x. I'll get 1x and 7x and put them together for the and then I've got a 1 times 7, which will be 7. And you see how those things are starting to line up to where we can combine them. This one I need to be a little bit careful with. It's a subtraction right there. So after I distribute, then I need to make sure that I'm subtracting both of those. So it's almost like you're distributing that negative sign, both of those. Like it's a negative 11 times x and a negative 11 times 2. That would give me a negative 11x and a negative 22. And that's where we are right there. We need to combine some like terms. So let me get rid of all this mess that I shouldn't have written in the first place here. And that'll give us a little bit of room. Hopefully it'll be just enough. And what are we writing in here? Green. So I'm going to take these 4x squared and these 1x squared and get 5x squared there. And I'm looking at these 8x and these negative 11x. So that's going to be negative 3x. And then lastly, I've got a negative 3 and a plus 7 and a negative 22. What is that going to be? That would be a plus 4 minus 22 would be a negative 18 if I did that right. And on the bottom, we're just going to leave that like it is for the moment. I would suggest trying to go one step farther and going, will that top factor? Because if you could find an x plus 1 or an x plus 2, that would be one more thing you could get rid of. And we like getting rid of stuff. You got that 5 out front. 5 is not a factor of 18. So, we're kind of, I don't know. Let's see what happens. I got a 5x and an x. Need some factors of 18. Of course, those are going to be 1 times 18, 2 times 9, 3 times 6. 4 doesn't go in, 5 doesn't go in. We've already got a 6, so we're done. There's only 3 possibilities, but there's a whole bunch of ways these things could get stacked up. And I want to get some that multiply to 18. And then when I include that 5 there, they need to, let's see, my signs are different. The big one's negative. So they need to subtract to negative 3 or, add to there, whatever you want to call that. Okay, I don't think we're going to find this, but let's see what happens here. Again, I kind of like to start at the bottom and just see what happens. If I put that 6 here and the 3 there, that's going to give me a 30 minus 3 is 27, way too big. So I'd be inclined to put the big number over here and the little number there. That's going to be 15. Minus 6 is going to be a 9, not a 3. So the 3 and the 6, just either way that you put them, are not going to work. So let's get that out of there. And we'll try something else. Moving along to the 2 and the 9, I could have, again, let's put the big one. Where did my thing go? Here it is. Let's put the big one over here and this one here. When I go this way, I'd have a 10 minus a 9 would be a 1. Or if I did 9, if I did it the other one, put the sign, I'd have 9 minus 10 to be negative 1. I need a negative 3. So that's no good. We could try flipping those two around, putting the 2 here and the 9 there, but I don't think that's going to work either. I put the 2 here and the 9. No, I think that's what I did before. Let's put the 9 here. Yeah, this is what we need to do now. And the 2, the outer is going to give me 10, and 9 is going to give me, 1. Still not a 3. So that didn't work. And if anything's going to work, it's got to be that top one. And I don't think it's going to work. Put the 18, put the 1, that'd be 5. Minus 18 is negative 13. If I do it the other way with the 18 here and the 1, that's going to be a huge number, minus 1. Still isn't going to work. All right. So this one just does not factor. we're not getting it to move. Okay. And as such, we can't do anything with the top. We could combine the bottom, and here's where you kind of got to, ask yourself, what is it I want to do with this, and would it be better or worse if I combine that? I'll show you what that looks like, and I don't know which one's better. Um, we're leaving the top alone. Down here, I'm going to FOIL the denominator, so that would be an x squared. Plus 1 plus 2 would be a plus 3x, and plus 1 times plus 2 would be plus 3. Okay, so this is a perfectly good answer. The thing in green right above it, perfectly good answer. Which is better? Which is preferred? I don't know. I kind of like the bottom one, I think, but that's just me. Who knows? Anyway, that's a little bit about rational expressions. Try to factor it, try to cancel stuff. And if that doesn't work, you just put a circle around it and whatever. If you're adding or subtracting, you got to have a common denominator. If you're multiplying, you don't. And off you go. Thanks for stopping in. Have a great day.